Cartesian coordinate system. Let's talk about graphing. Whenever we talk about graphing points on a graph, we're usually graphing it on a Cartesian coordinate system. And that coordinate system is made up of an x-intercept and a y-intercept. The x-intercept is this vertical line right here running straight through the middle of it. And whenever we read the graph, we start with the smaller side first. So we're going to start on the left-hand side. And right here, when we start on the left-hand side, we know it's negative infinity. And it's going to go dot, 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 negatives all the way up to the origin. What do I know about the origin? It's the center. And that means that x is 0 at that center. And then we're going to move to the right steadily. And as we go, we notice it's going to go off to positive infinity. All right, so that's my x-axis. Now, whenever we look at this horizontal line that runs straight through the origin, it's my y-axis. And we always start at the bottom. We're going to read the top to bottom. Okay, so again, the x-axis, we read left to right. The y-axis, we read bottom to top. All right, at the bottom, we start off with negative infinity and we go up, dot, dot, dot to the origin. What do I know at the origin? It's the center. That means y is 0. And then on the other side is all positive numbers. And we keep going up, we'll go up to positive infinity. Let's just talk again about the order pair. The order pair is our independent variable, comma, dependent variable. That's how we write an order pair. And remember, the order pair has the parentheses on it, guys. It's inside something. Later on, when we talk about inequalities, we'll talk about brackets and parentheses. But right now, we're just talking about a specific order pair. They're in parentheses. My independent is my x. My dependent is my y. This tells me y depends on x. Okay, so let's talk about this coordinate again, this graph. Whenever we talk about the graph, we already discussed what the origin is. It's the center. Both x and y are 0. Quadrant 1 is this first quadrant, and in it, x is positive, y are all positive values. Quadrant 2, look at it. My x are all negative values, and my y is all positive values. Quadrant 3. My x is all negative values, and now my y is all negative values. Quadrant 4, my x is all positive values, and my y is all negative values. So determining where they fall on the quadrant on this graph helps to know that where the x's and y's are positive versus negatives and what the origin is. One more thing about the graph, though. Whenever we're talking about plotting points on the graph, if we cross the y-axis, if it's a horizontal line, we cross it, or an angle, we cross it, wherever it may be, that is going to be my y-intercept. And what do I know at that particular point? I know that x is always 0 and y is some number. Now, whenever we cross the x-axis, if it's a vertical line or an angle, wherever it may be, we know that that's the x-intercept. And at that particular point, y is always 0 and x is some number. Okay, so these are important, helpful informations to know. So let's talk a little bit more about graphing. Whenever we graph a line, later on we may talk about graphing hyperbolas, circles, eclipse. I mean, we can go in depth, on talking about how to graph and plot specific shapes. Right now, we're just going to talk about graphing a linear line, and linear line just means that it's a straight line, however direction it may go, and the powers on x and y are all to the first power, okay? Now, the slope, the formula for it is, well, we need 2 order pairs. We need 2 order pairs in order to graph a line, any line. So this subscript right here just tells me that this is order pair 1 and this is order pair 2. So in order to figure out the slope, mathematically, we're going to say the y from the second order pair minus the y from the first order pair divided by the x from the second order pair minus the x from the first order pair. There's other ways of actually figuring it out by plotting the line and then determine it, but that's later on. So anytime we get y2 minus y1 equals 0, then we're going to have a horizontal line. And that means the slope is 0. Just think about the horizon. It's the beginning of the day. We start out at 0 when we start counting, right? 0 to 1 is 1. All right. That means that the numerator has a 0 and the denominator has some number that is equal to 0. Helpful hint to always know. If x2 minus x1, if x from the second order pair minus the x from the first order pair is 0, well, that's a vertical line. And that slope is undefined. And one way to understand this is you cannot hang a picture on the wall without some kind of support. You cannot walk up the wall without running or having something to help you walk up the wall. So a vertical line has an undefined slope. That means that my fraction looks like some number on top with 0 on the bottom. This is undefined. That's not going to equal 0. Also, if my slope is a positive number, then that means that we're going to move my particular point up the number of y's and to the right number of x's. There's more than one way to graph this, but this is the most simple, straightforward one. What do I know what I'm moving? Well, in order to plot the slope, we have to first plot the y-intercept. From the y-intercept, we plot the slope. Okay, so from wherever point that is, so let's just say, and I'm going to erase this right here. Let's say that I have a y-intercept. Let me think. Let's pick a pretty one. Let's say that we have a y-intercept of 0, because remember, x is 0 when we cross the y-axis, 2. So it crosses right here. There's my y-intercept. So I'm going to plot it first. Wherever, so we'll plot it. So whatever my slope is, so let's just say we have a slope of 2/3. And it's a positive slope. That means we're going to go up from here, 1, 2, 3. Oh, excuse me, read it wrong. My y value is the top number, right? It's y over x. We're going to go up 1, 2, and then to the right, 1, 2, 3. That would be my slope. And then we would like connect the dots, right? So all we need is 2 order pairs. Let's connect it right here. And there's my line. So if you notice, if it's a positive number, my line rises left to right. I'm gonna make me some space here. Erase this here. Let's get us some space right here. All right, so now let's talk about if my slope is negative. If it's negative, then we're going to go down the number of y values and to the right the number of x values. And where are we going to plot it from? We're going to plot it from our y-intercept. So again, let's use this y-intercept of positive or 0, positive 2. So from here, I'm going to go down and let's use the slope of a negative 2/3. Let's do that. So we're going to go here at where it crosses the y-axis, and we're going to go down 1, 2, and then to the right, 1, 2, 3. And then I am going to connect these two dots. My line's not perfect straight. And then I got my line based upon the slope-intercept form. Okay, from here, I notice that if my slope is a negative number, that means it falls left to right. Okay, so this is talking about graphing, figuring out the points, where it's at on the graph, and what does it mean. So let's plot some points. So right here, I got an example of one. Let's talk about this 3, 5. Whenever we plot our x, y, we always plot the x first and move up or down for whatever y is. And where do we start? We start at the origin. And what is the origin? It's where x is 0 and y is 0. It's the center. It's right here. So we're going to go over 3 to the right because it's positive for x, 1, 2, 3. And y is positive, so we're going to go up 5. 1, 2, 3, 4, 5, and there's our point. So you kind of get the idea. So let's use these points below and let's graph those. Okay, so the first one here is a positive 1 for x and a negative 7 for y. So I'm going to start at 0, 0, the center. I'm going to go over to the right one because it's positive for x. I'm going to go down 7 for y because it's negative. So we're going to go 1, 2, 3, 4, 5, 6, 7. And we're going to plot that right there. I'm going to call it A. And where does that fall? That falls in quadrant 4. Let's call this one B. So we're going to start at 0, 0. What do I know? X is 0. So I'm going to stay on the origin or on this line, on the y-axis, right? Because we're going to go up because y is positive 1, 2, 3. And this tells me that it's the y-axis that it's located at. And we're going to call this B. Let's call this one C. Let's start at 0, 0. And x is negative 5. So we're going to go 1, 2, 3, 4, 5 to the left. Make sure 1, 2, 3, 5. Okay. And y is 0, so we're not going anywhere. So we're going to stay right there. And that tells me it's the x-axis. Now let's look at this next order pair. Let's call it D. Start at 0, 0. X is positive, so we're going to go left, or excuse me, to the right. 1, 2, 3, 4, 5, 6, 7. Up. I put my dot. Let's just hold off on putting our dot. Let's just hold it there and look at y. Y is positive, so we're going to go at 1, 2, 3, 4, 5. Oops. Make sure I can get my pencil. 1, 2, 3, 4, 5. There we go. And that is located in quadrant 1. Now let's call this one E. Let's go back to 0, 0, the origin. And x is negative, so I'm going to go to the left. 1, 2. And y is positive, so I'm going to go up 1, 2, 3, 4, 5, 6, 7. And that's my E. And that is in quadrant 2. So let's do this one and call it F. Start at 0, 0. X is negative, so we're going to go to the right one. Or excuse me. X is negative. We go to the left one. And then we're going to go down because y is negative. 1, 2, 3, 4. And there's my F, and that's quadrant 3. Okay, so that's plotting and locating those points. So let's do one more thing. Let's do an example. All right, now when we're doing application problems and we're going to plot the graph, remember my x value is my independent value. My y value is dependent. That tells me y depends on x. Y depends on x. So in this example, I said I have a small pizza that costs $5. Each additional topping is $2. So what does this tell me? This tells me that the cost is my y, right? So it's going to be 5 plus whatever I add on if we add additional toppings. If not, then we're just going to have $5, right? Let's say we're going to add one topping. So, or two. Let's do two toppings. Let's just do that. All right. Then that means X is 2, because that means each topping is $2. Then that means I got to add 2, however many times I need to have, to show for the toppings. So if we're adding 2, I'm going to put $2 plus $2 here, which is what, a total of 9. So this order pair is 2, 9. So I can come over here and start at 0, 0. And since X is positive, we're going to go to the right 1, 2. Y is positive, we're going to go at 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's my order pair. It's plotted on the graph. Now, if you wanted to determine if there's a increase in sales or a decrease in sales, well, then we need another order pair, and then we'll be able to determine the slope. The slope, remember, will tell me if I increase or decrease. How do I know that? That's if the slope is a positive number, then that means we're increasing by however the number is, right? If my slope is a negative number, then that means it's decreasing by whatever the number is. If my slope is 0, well, then it's constant, right? And if it's undefined, then we got some issues we need to work out. But that was an example of how to work plotting and using a Cartesian coordinate. Thank you.